In the 2025 to 2026 academic year, the Central Board of Secondary Education digitized the evaluation of its board exams, moving to an online portal called on-screen marking. Over 1.7 million students took those exams, and their final grades and academic futures were entirely dependent on the integrity of that single platform. Within days of the portal going live, independent security researchers discovered it was entirely open to unauthenticated account takeovers. CBSE released a public statement categorically denying any security flaws existed. Yet, layered right behind that official denial is a screenshot of the actual administrative dashboard, accessed without a valid account. To understand exactly how a national grading system was left this exposed, we have to synthesize the digital forensics published by two independent researchers, Nisarga and Sarthak Sidhant. The platform's collapse was a dual failure. The code was written poorly, but the government's procurement rules were manipulated to ensure that specific code was deployed. We are going to conduct a forensic teardown of both the software architecture and the legal contracts that put it into production. The portal was built as an Angular single-page application. This means the entire front-end logic is packaged into one minified JavaScript file and sent directly to the user's browser. The developers hosted this JavaScript bundle at a public static URL. Anyone, logged in or not, could download it and read the exact logic powering the application. This diagram of a code editor highlights what researchers found inside. Sitting in plain text was a hard-coded master password string. When entered, it triggered an automatic bypass, skipping the one-time password and logging the user in without checking the server. The implementation of the one-time password verification revealed a deeper architectural problem. This schematic contrasts secure server-side validation against the portal's client-side validation. Because the browser graded its own test, attackers could simply open the network tab, intercept the server's response, read the true OTP, and submit it. Even if an attacker skipped the login screen entirely, the application's routing configuration offered zero resistance. The developers failed to include any route guards in the Angular code. A visitor could open their browser console, inject a fake JSON web token and a role ID into their local storage, and navigate straight to the internal dashboards. The application never verified the session with the backend. Moving from the front end to the backend APIs reveals even more severe data mishandling, starting with the password reset endpoint. The API payload required to change a password only asked for a new password. It completely failed to collect, transmit, or verify the user's current password. This flaw became fatal when combined with an insecure direct object reference, or IDOR, vulnerability built into the core architecture. This visualization shows the server identifying the user by pulling evaluator ID straight from session storage. An attacker could manually swap this ID to target a victim, triggering a password reset. The server accepted the change with zero verification. By seizing an examiner's account, an attacker gained full read and write access to the live evaluation dashboards. They could view assigned answer scripts and manually alter the marks of high school students. Just days before the platform was finally pulled offline, researchers also discovered and reported an active SQL injection vulnerability. Every single exploit in this chain traces back to the exact same design flaw. The developers place their trust on the user's local machine instead of the server. A software stack this flawed does not reach a national production environment by accident. It is the result of a compromised procurement pipeline. The platform was developed by a company called Coempt Eduteck, an entity previously known as Globarena Technologies. Under the name Globarena, this same firm operated the software for the 2019 Telangana intermediate exams. System failures in their code caused 3.8 lakh students to fail due to missing marks. We have to ask how a vendor with a catastrophic, publicly documented track record secured the contract to handle the CBSE national board exams. This graphic places the canceled May 2025 request for proposal next to the finalized August 2025 version, revealing how the rules were completely rewritten. The May contract contained a clause instantly disqualifying vendors who had a record of poor performance or who were blacklisted earlier. In August, that specific text was deleted. The new contract only required that a vendor not be currently blacklisted. Since Globarena had rebranded to Coempt Eduteck 6 months after the Telangana crisis, this single edit effectively sanitized their corporate history. The board then artificially adjusted the financial and technical baselines to fit this specific vendor. The contract set the minimum turnover at exactly 50 crore. Coempt cleared that line at 50.86 crore, barely blocking smaller competitors. Then, as this maturity ladder shows, the required software certification dropped from CMMI Level 5 down to Level 3. The physical infrastructure requirements were similarly hollowed out. The original mandate required the service provider to own their own local Tier 3 data centers. The August revision allowed the use of third-party cloud hosting. This directly accommodated Coempt's existing Amazon Web Services deployment, removing the competitive advantage of larger IT firms that owned their own servers. The board also deleted the clause requiring the vendor to own the complete source code of their software. This permitted Coempt to rely on proprietary Microsoft platforms to run the portal. The technical evaluation matrix was restructured. Instead of grading vendors on the volume of pages scanned in a single order, points were awarded based strictly on the total number of past projects, heavily favoring Coempt's portfolio of small, fragmented university contracts. Right before bidding closed, a final corrigendum was issued. It entirely erased the board's legal right to blacklist the firm if they repeated catastrophic mistakes. The service level agreement was altered as well. Penalties for inaccurate or merged scanning were replaced with flat daily fines for missed deadlines, directly incentivizing the vendor to rush the grading process. Finally, the contract mandated a strict security audit of the production environment before launch. Yet the live portal was deployed with glaring plain text vulnerabilities. The technical safeguards were systematically dismantled. The procurement rulebook was manually edited to ensure a specific, underqualified vendor won the bid. This timeline maps the collapse. The manipulated August 2025 contract triggered the deployment of insecure code in February 2026. Researchers submitted a detailed vulnerability report to CERT-IN then, met with 3 months of complete institutional silence before public exposure in May. When the media finally picked up the story, CBSE issued a public statement denying all vulnerabilities. They even initially directed reporters to a completely different, non-existent domain. That institutional denial collapses against the public record. Researchers preserved Wayback Machine archives of the source code, verified load balancer DNS entries, and documented access to live production data. The on-screen marking disaster is a holistic failure of both software engineering and public administration. Over 1 million students were treated as involuntary test subjects for a grading system stripped of digital and legal safeguards. In systems architecture, the core rule remains. Client-side validation is inherently compromised and cannot be trusted. When a government actively rewrites its own procurement rules to protect incompetence, the institution itself becomes as untrustworthy as the code it deploys.